This is the pop test, the electrical pop test. I just wanted you guys to take off the top of your head. And this is sort of, this was launched from the class discussions we've had and the things I've told you in class and what we've covered on the board. And part of our plan of instruction for the state of Alabama's automotive curriculum is you're supposed to list, define, explain, and all that stuff. In other words, you're supposed to be able to say stuff off the top of your head with no notes. And if I gave you guys, but since you guys really didn't do all that well on this test, I have to give you several more. I've actually got one with really some pretty tough wiring schematic stuff that I'm going to throw you for your next pop test. I've been building those in the morning when I was really alert and sharp, and I would just pull them from here, there, and yonder and ask tough questions about them. And you got to be able to dig through them with schematics and all that. Okay, let's look at this first question here, and let's talk about what the question is. Technician A says the best way to find an intermittent wiring problem is to disturb as many parts of the wiring harness as possible to see if the problem goes away. You just jerk on the harness and see if you can make it quit doing it, right? Technician B says a problem that evaporates without actually being fixed won't usually reoccur. Now, which one of y'all, who got that question wrong? All right, you got it wrong. So
I'm saying that it's because I've been stuck on the side of the road with an intermittent wiring problem before, and the best way to get back home is to go under the hood, go back in the car. Does it start up? No. Go back under the hood, fight with that wire harness, wrestle with it.
Yeah.
It starts. Okay, we're going home now.
Yeah, well, you really don't know what the problem was, and what happens usually is that the harness goes right back to where it was, and after a while the problem comes back. Now, if you're trying to fix somebody's car like that, you're typically, moving toward a comeback there. So basically, the right answer to that question was what? Neither one of those guys is right. If a problem evaporates without actually being fixed, it will usually reoccur, and that's a comeback. What happens there is they come back and they say, hey, you fixed this car, we charged them an hour labor, and now it's back again, and since you're working on commission, you're going to have to fix it free. You know what I mean? That's the only way to do that, because if you just could, patch it. But I tell you what, there was a little old lady that I know that took her car, and granted it was an old Oldsmobile or something, to a shop over there in town, where me and Daniel live in that town over there, and she went, I'm not going to say the name of the shop, but she went over there and she I don't remember, the car wasn't running right, and it was an old car anyway, and so they put a fuel filter on it and charged her $85 or something and sent her on her way. Well, she got across town and a whole bunch of gas started coming from under the car, and so she called them up and they sent a wrecker to get the car, and when they got it back over there, the fuel filter they put on was leaking because they didn't put it on right. So they fixed the leak, but they made her pay them to fix the leak, and they also made her pay for a wrecker bill. Now she's a little white-haired old lady that probably 80 years old, and she didn't really have the guts to stand toe-to-toe with them and, have a fit about it. So she just paid them what they charged. But that's the kind of stuff that goes on nowadays in some of these shops, All right, now then,
Better Business Bureau.
Yeah, we got a parallel circuit here. We got a parallel circuit with 3 10-ohm resistors in parallel, right? The resistance of the parallel circuit shown above will be approximately what?
3.3.
3.3. Now, who got that right and who got it wrong? Raise your hand if you got it wrong. All right, now, why did you guys get that wrong?
Because I couldn't remember the parallel.
If it was, listen to this, if it was 2 10-ohm resistors, what would it be?
5.
5, that's right. See that?
Being divided by the number of paths.
See, you got more paths, it's going to reduce your resistance, isn't it? Because there's more places for vehicles to go. Let me ask you this. Let's say that you were waiting at the voting booth and there was a single line of people 30 long, right? Or maybe at the grocery store checking out. Every time they open up another place to go and do the same thing, the thing moves faster, doesn't it? If everybody's getting choked through this one little line, like if you got one place at Walmart, you got a whole lot of people, you got 15, 20 people in line at Walmart through one checkout. They open another one to speed things up, don't they? Okay, so what we're going to do is we're going to provide another path for current flow, and it's going to speed things up. So there's less resistance. Things go faster when there's less resistance. Does that make sense? I mean, does it? You get where I'm going with that?
Why don't they just have one path with 3.3 ohms?
Huh? Oh, well, because basically if you're working with networks and multiplexing, all of these modules have got a terminating resistor in them. And those if you go to your network, let's say you two wires that go to that network, and you measure unplug your battery, make sure everything's bled, the capacitors and all the modules are bled off, and you get your ohm meter and you hook it up to those two wires, and all of those terminating resistors are going to actually, they've got various different resistances, but they're going to come down to one, like a lot of times it'll be like 60 ohms, depending on how many modules you got. So if you know that particular car is supposed to have 60 ohms of resistance with all those parallel termination resistors and all those modules, and it's less or more than that, you either got an open circuit or something shorted. You get where I'm going? That's how you do that. But anyway, you need to know that, because there's a lot of times whenever you, in these 21st century vehicles, when you need to know how to figure that stuff up. And as long as you understand, that's part of your Ohm's law thing. Technician A says the test light, this is number 3, or DV-OM probe must be inserted firmly into the terminal of a fuse or relay socket to ensure a good connection. And Technician B says intermittent terminal connections can result from improper use of test probes on terminals. Who got that one right? You get it right? Okay, what happens if you ram that thing in there good and solid?
Well, we've been learning to back probe when possible and be gentle with the connector, because you sit there and just jam that thing in there and you're going to cause intermittent connection issues after you plug it back up, because it's not going to seat properly.
Yep, and General Motors wire harnesses, the General Motors instructors will tell you that on a GM car, if you unplug some of those connectors 4 times and plug them back in without doing anything to them, you're going to start having pin fit problems.
That's one time with the neutral safety on the transmission.
Yeah, you saw that, didn't you? Yep. All right. So anyway, if you don't take your test light probe and cram it down there. I told that one day. One day when I was in there, I said, now when y'all are checking this engine coolant temperature sensor connector, make sure that you just touch the probe to those terminals, And I went out there, and this was back in 2004 or something. And those 2 students went out there, and there's a little 3-pronged connector that was hooked up to that sensor on that Oldsmobile. They rammed these all the way in there. And you know what that did to that connector? It just destroyed it. I actually had to buy another connector for that doggone car. It's a terrible mess. But anyway, right after I told them not to do it, they did it anyway, So anyhow. All right, so don't cramp the test light too. The test light probe is nice and tapered, and it's just made to wedge in there and spread them things apart. And they stay where you spread them to when you pull it back out. And then you plug your connector in, and you got this. Nothing's touching anything. And now all of a sudden something don't work. I've seen that, and I tell you where you'll see that a lot of the time. And I had one that smacked me around a pretty good bit one time on an Explorer or something when something didn't work, and I tracked it all the way back to the fuse panel, and it turned out that, and I don't know why I didn't catch that sooner, but you could jiggle that fuse, and it would get. And then when I unplugged it, they had a cell phone or something in there, where you put them little thing around the fuse and plug it in, and they had spread those terminals. And so basically I had to just tweak the terminals with my little pick to get them back like they were supposed to. But that had smacked me around for a while, because I knew the fuse was good, and when I measure it with my test light, that's why sometimes I'll break a terminal off of a fuse and stick it in there, so when you guys test it, it'll look like it's good, and when you pull it out, because this spread terminal in the fuse panel will have the same effect. You'll check both sides of the fuse. You better pull it out and look at the pin fit of those terminals. That's important. Because it'll be spread if somebody's had wire wrapped around it and crammed in there to try to make a connection to something. Okay, when a component is drawn with dashed lines rather than one drawn with a solid line, like this one right here. Let's see, let me go over here. What does that mean? What does it mean when it's drawn with dashed lines instead of solid lines? Who got that one right? You two guys got it right. Sean crashed and burned on that one. Okay, so it means that you're only seeing part of it. There's more to the component than what you're seeing. That's what that means. Got it? So if you see, like the junction box, it may show a couple of fuses. There's more than 2 fuses in the junction box. And well, right over there, you see that on that schematic that's up right now? That component that's drawn with dotted lines, there's more to that component than they're showing you. That means you're not seeing everything that's in that switch. There's more in it than that. So just remember that. Now that was question number 4. All right. I need to make some more of these, don't I? Is this most instructional to you guys?
I kinda like this.
You having a good time with that? When tracing a short or an open, which connectors on the circuit should be examined first? Who got that one wrong and who got it right?
Yeah, right.
Who got it wrong? Raise your hand if you got it wrong. All right. So what you supposed to check? What's the right answer to that?
Most easily accessible.
Yep. Now, back when I first learned how to read wiring schematics and I was doing wires, I'm a sequential kind of a person. You know what I'm talking about that? When I used to load my own ammo back years and years and years ago, and we'd shoot pistols down at the gully, and I always liked to get on that box of 50 that I had. I had a plastic box, you know, that had my reloaded 45 long Colt ammunition in it. And this guy, I would always start on the corner of the box and I'd pull out the first 5. And I wouldn't put 6, I'd pull out the first 5, put them in 5 in there for safety and an empty round. All right. So then when I shot those, I'd put the next 5 in there and the next 5, and I'd work my way across the box like that. Well, this one guy that was a computer science guy that wasn't sequential, he was sort of random. I says, okay, get 5 bullets out of this box and put it in the revolver. You know, he's going to shoot it. He reaches right into the middle of a brand new box of ammo and starts pulling rounds out. And I'm like, no, that ain't the way you do that. You know, but some people have a tendency to just go crazy. Now, there are times when being a little more random is good, but you have to have a system to everything you do. I would start, if something's starting at the ignition switch and it's going out here to a certain place, I had a tendency to want to start at the ignition switch because that's where everything started. So I'd get the ignition switch. Do I have power there? Yes, I do. Is it going through the ignition switch? Yes, it is. And then I'd work my way up through there. And sometimes I'd find myself doing a bunch of hard work looking at something that wasn't the problem and find out that the connector that was where the problem was right out there on top of the engine. And it was easy to get to. And so if you look at all your connectors and you see one right on top of the motor that's in that circuit, let's look at that one first. And let's see the side, let's go to the side that's supposed to be getting power and check that one. And then let's see if there's power going through that connector. And I've actually, you know, worked my fanny off, and whenever I saw the one on top of the motor I should have looked at first, I said, well, that connector is not even seated good. And I'd go click and my problem would be gone. And I could have done that instead of, you know, going under the dash and looking at the ignition switch. So find the one that's most easily accessible, check those first, and work your way that way. Back to the one that's the toughest to get to. For instance, on that Ranger out there, there's 3 square connectors right below the master cylinder between it and the fender that's really a pain to get to. They're big square connectors, and a lot of stuff goes through those things. Now, I used to have to break into those connectors a lot when I was working at the Ford place, but you might notice that even now I'm not too terribly prone to plant bugs so that you got to go to hard to get to connectors. But understand that you're going to have to sooner or later access a hard to get to connector.
Didn't I have to clean the pins on that?
Huh?
Didn't I have to clean the pins on those?
On the, not really, not on those because they're sealed and they're usually really clean
You
anyway.
made me clean them.
Huh?
You made me clean them on the Ranger.
Which ones you talking about?
The kick panel.
No, yeah, well, that's not the ones I'm talking about. These right here are 3 big square connectors, and each one of them's got a bunch of wires in it. And they got a bolt going through them that cinches them together. That was a different one. You're thinking, I remember that, but that was a different connectors. But, okay, now then, when testing a hard fault concern indicates a possible faulty engine controller and a properly working identical vehicle is available for parts comparison, such as a used vehicle that belongs to the shop, how should the PCM hypothesis be tested? Now, who got that one right? Anybody get it right? Nobody got that one right. All right, let me tell you about this. I had, one day, I was, when I was off, I was working on this 91 F-150 that belonged to my friend Alan Waters. And I went over there, and this thing was running like trash. It was just terrible. It was making buzzing noises in the relays, and it was firing the coil randomly and just doing all kinds of crazy stuff. And I checked the grounds, and I checked for wiring connections and all that kind of stuff. And I came down to the point that this thing was probably going to be a bad engine controller. However, listen to this. This is important, guys. I did not know what destroyed that engine controller. If indeed the engine controller was bad, why was it bad? Well, did it just fail because of its own, you know, innards going bad, or was there something that had destroyed it that was wrong with the truck. Well, his daddy had a truck just like his, except it was a different color, and it was four-wheel drive, but it had the same engine controller in it. And so the smart thing to do was not to take the engine controller off the good truck and put it on the bad truck. Why is that not smart? If the bad truck fried the engine controller, it's going to fry engine controller number 2. Now we need 2. You get me? All right. Now, the smart thing to do, of course, we're still got a little bit of a pig in a poke there, but you unplug the engine controller off the bad truck. An engine controller on a bad truck is probably not going to hurt a good truck. The engine controller is more likely to be damaged than the truck. So I take the engine controller off of the bad truck and I take it and I plug it into the good truck. And then what happens? The good truck ran terrible, just like the bad one. So I knew it was the engine controller. Well, when I get another engine controller, if I put it on there and it doesn't work, then I've still got issues. See, but in that particular case, I didn't. We bought one for $100 from the parts house, plugged it in, we're hunky-dory. We're in Fat City, everything's fine. All right. Now then, so basically what you're going to say is connect the suspected faulty PCM to the properly working vehicle. That's true if it's any kind of an electronic component that you suspect being bad. Don't ever pull one off of a good car and put it on the bad car. Always go the other way, and you'll keep yourself from destroying somebody else's good part. If there's nothing wrong with the truck, you want to keep it that way. You know what I mean? The other truck or whatever. Now, if you've got a part laying in your box, you know, that's one thing. Okay, the measured resistance of a particular tail light bulb is found to be 2 ohms. You've measured it with your meter and you found it to be 2 ohms. Connecting the bulb through a digital amp meter to power and using the E equal I times R formula, rather, the bulb resistance is calculated to be 6 ohms with current flowing. And what I mean by that is you've actually measured, and you can tell by doing your math on your Ohm's law that now it's 6 ohms. Now, Daniel was the only person that of all you guys that took his test that got that one right. And I think he kind of guessed at it. But he still got it right. Now, what happens with that bulb, let me ask you this. If that bulb, if the resistance of that bulb stayed 2 ohms, right? If you go by your Ohm's law thing, you go by your Ohm's law, E-I-R, all right, if that's 12, and this is, well, this is 2, and that's 12, what's that going to be? 6 amps? My goodness, that's a lot of amps for a tail light bulb to pull, isn't it? So what happens when you fire that bad boy up? The resistance increases. It's got 6 ohms of resistance whenever the current's flowing through it because it's positive temperature coefficient. See that? As it gets hot, the resistance goes up. Just remember that. You can demonstrate that if you actually do, if you do your, you know, one of these little boards with a meter and all that.
It's in there and heat a wire with a torch or something, or lightly hit with that thing.
It will do that. The resistance will go up. A regular wire will. The battery cables do that sometimes when they get hot under the hood, you know. So remember that. That was kind of funny, but several people said somebody needs to teach this bozo to read a DVOM. I mean, several people checked like the answer.
Well, see, I got mixed up with it saying meter to power. I was thinking they got power running through it when.
Well, they did. They're supposed to have. See here?
To check ohms?
Well, no. You were getting the amps so you could calculate the ohms. So you take your meter and you put it on amps. You know, you got 3 holes on the meter, and you actually put this one here and that one there instead of the other way around. You set it on amps, and then you hook it up from your power to your load, just like a jumper wire. See, when you got that like that, you're reading your ohms right there. That's how that works. When you read your, not your ohms, your amps. When you read your amps right there, and then you use that amp reading to determine what your ohms is, you can find out how many ohms that thing's got whenever it's burning. And it's going to be less. I mean, it's going to be more ohms when it's burning. Okay. And also, when you turn on lights, if you were using an inductive pickup, when you turn on lights, if you got it on a graph, it's going to go up, and then it's going to come down and level off. See that? I mean, that's the way that works. You know, it goes up and then down. That's why you gotta have a fuse that will actually be higher than that, so that it won't spike up and pop the fuse when you turn the lights on. All right, now then, let me see here. Technician A says ECT, IAT, and transmission oil temperature, which would be TOT, sensors are all thermistors. Technician B says these sensors are generally positive temperature coefficient sensors. Who's right about that? Who got that one right? Yeah. Mr. Webb, he got it right. So do you remember that from class or something? You just guessed. Oh, that's not good. That's it. I got to give you 7 more tests now. All right. So, what is it? Positive temperature coefficient? Did you actually put neither one of those guys, didn't you? Or did you put A? You put technician A was right. Yeah, technician A was right because they are thermistors. But positive temperature coefficient sensors, the bulb is positive temperature coefficient. The sensors get less resistance with heat. So the hotter a sensor gets, the less resistance it has, and it's backwards than a bulb. See, it's different. Just remember that. At the end of a 3-minute charge test, the voltage reading for a satisfactory 12-volt battery should not exceed how many volts? 15.5. If it exceeds 15.5 volts, then it's a sulfated battery and needs to be replaced. I mean, that is a go, no-go test, guys. You know, if you're doing that and somebody's got maybe a starting problem or something like that, you put that charger on there, you let it charge for about 3 minutes on a pretty strong charge, like 40 amps or something. You hook your meter up to it, and if it climbs up above 15.5 volts, you can say, that's it, we're done, this battery's sulfated. Now, you may have other problems, but we know good and doggone well this battery ain't no good.
It's sulfate, that means that it's
the plates are coated with sulfur. Sulfuric acid, you know, the plates are coated with sulfur.
So you can't just drain the battery fluid out of it and put some distilled water in a...
Sometimes people that would take old batteries and rejuvenate them would do that. They would empty the battery out and they would try to clean it out. But a lot of the times there'll be crud that has settled in the bottom of the battery when you turn it over, and it gets up in there between those plates and shorts them out. Sometimes you can get away with that, but you're not going to make it into a new battery by doing that. It's just not happening. I mean, some of the people used to do that. They'd take a little, and basically the rule of thumb, they'd say, like if you go to this place where this one guy did that with a lot of batteries at a filling station over in Dothan, he would actually check and see how many cold cranking amps the battery had. If you had a 350 engine in your pickup and he checked it and it had at least 350 cold cranking amps, he'd say you're okay. 1 cold cranking amp per cubic inch will get you by. You see, basically. But that long and the short of it was none of his batteries were guaranteed. He sold them cheap, but basically he just dumped the stuff out, put distilled water in there and try to clean it up as good as he could. He may have some chemical he put in there too, I don't know.
Don't you still have to put not a catalyst, but
acid.
Yes,
Yeah.
like you do for hydrolysis.
Well, you've actually got an electrolyte that you can buy.
Yeah, electrolyte.
Yeah, electrolyte that you can buy plastic jugs of electrolyte and do that. And you know, acid don't eat plastic.
You just use baking soda or something?
Baking soda is alkaline. Yeah, it's not acid.
It's an alkaline battery.
Yeah, well, go figure.
Yeah.
All right, it's already been acid. All right, let's see. A waveform displayed on a waveform displayed on a lab scope is basically a graph of what? Voltage over time. That's what it is. Okay, now, do you guys feel like if I threw you another test similar to this one that you could probably do pretty good next time? You ready for the big hoss of a wire harness test that I got? It's got wire schematics on it with questions about those wiring schematics. Can you handle that? The reason I'm going through this stuff right here is my final for electrical that you guys are taking has got some it's got wiring harness pages on it, and there's questions about those wire harnesses that you have to answer, and it seems like just about everybody has a hard time with those. You know, you study wiring schematics and you fix the cars and all that kind of stuff, but when I give that part of the final, it's just a part of the final where there's about 3 or 4 pages and they've all got wiring schematics and they got specific questions about the wiring schematics. And all you have to do is just look at them and think about them and apply logic and reason. But I think for some strange reason, after they answer the first questions on the first part of the test, when they get into that, they figure, well, there's only a few of these, I'll just blow past these, you know, and so we don't do that. Okay, now, here's something else. Did you learn something about that? This test here, if you try to guess your way through a test, you don't generally do that well, right? You got it? So, my tests are open book. basically.
Hypothetically,
Yep.
you could pick C or D as what they say about them standardized tests and make a certain score generally. I
Yep.
don't think you could have done that with this one.
Not hardly, because I kind of put the questions all over the place. It was really funny too. Everybody's going to have a test for electrical. Will be all the same. Everybody will have a test with different questions on it. You know, everybody's got, and the fundamentals test is going to have 40 questions on it. Probably one question out of each chapter, or something like that. But I told that one guy, I says, I'm going to have different questions on everybody's test. Nobody will have the same questions at all. And he goes, ah, crap. What was he planning on doing? He's going to copy somebody's question. But anyway, you know, but on the electrical test, everybody pretty much have the same final exam. You know.
I would feel safe winging the fundamentals and performance engine
Yeah.
tests. Electrical.
Well, I'm going to throw you, I'm going to start throwing finals next week. I'm going to let you work your way through your written finals next week. We're going to try to make sure everybody is through with their written finals next week, and you'll have an idea of kind of where your grade is going to go that way. Now, a lot of these worksheets and everything are going to have to be knocked out, so you'll have a decent shop score, so be aware of that.